So now instead of the linear, I've changed them all to x squared. So if you're watching this video, I left off the linear family. So they all start out as that red guy. If I multiply him by 5, he turns really skinny. If I multiply him by a fraction, he gets really wide. If I turn him negative, he goes upside down. If I subtract something, he moves down. So the subtracting turned it from red to black. I could flip him on its side. Well, I wonder if I could. Let's see if I can. Uh-oh. How do I need it to be like, I think this might flip it. I'm not sure. No. There's some way that I can flip it. I just can't remember which one. Don't worry. I'm just your teacher. I'm supposed to know these things. But I can flip it on its side if I wanted to. I can shift it left. So like I can move him over. I just have to take that one off and unmute him. So now I have one that I moved to the left. I have one that I moved down. I have one that I moved over. Let me see if I can do that one more time. Nope, we need the X in there. Why doesn't that flip it on its side, is what I want to know. I'll figure that out. So, all of these parabolas come from this red one, this parent that goes through 0, 0. Are you guys kind of okay with this idea that I take this parent and then just do things to it and I get a bunch of graphs that look like it but aren't exactly the same? Is that making a little bit of sense? Are you sure? The defining characteristic of a quadratic is that he has a U shape. So then your next family, and hopefully you saw these guys last year, but I'm wondering if you really did based off of what the A days were doing. This guy's the cubic family. And his function is y equals x cubed, or x to the third. So this guy is, and this one it's hard to see, but he's like a roller coaster. So his basic function goes through 0, 0. He's like a parabola with one of its arms being broken down, like its left-hand side being broken down. And just like with all these functions, I can change this to an x cubed. And then mute these so that all you see is the parent. If I do crazy things to it, I might be able to get it to look a little bit different. So let me see if I can. Nope. Why am I having such? Okay, let me unmute this and see what it looks like. So he's not that much more exciting. So there is another one that's in the cubic family. The green one, he looks a little bit different. I can shift him left or down. Like if I put this one in, it's gonna shift it down. So that's the black one. It's been taken from 0, 5 to 0, -5. I can move it to the left just like I did the last time. So that's the blue one. Now he's over here. I'll mute that green one so you can see a little bit better. So any of them that look like a roller coaster function are in the cubic family. We'll see this a little bit later on in our lessons, but like eventually those cubics start to look like this, like a real roller coaster. So notice it has the same characteristic. It starts down here and then comes up, and here it's the same thing. It starts down here, has a little wiggle, and then comes up. Okay, anybody remember what this V family is? Starts with an A. It's a big one. This guy is the absolute value. And he acts like a parabola. He acts like a parabola. So instead of that U shape, he has a V shape. But everything else is the same. We can make him so that he looks really narrow. We can push him out really wide. We can move him up, down. We can flip him around. His function is x in the straight lines. And when you do those straight lines, you want to try to be careful to make them longer than the x so that they look like not a 1. So that they don't look like 1x1. They have to be a little bit longer than the x. So I'll try to go quickly on this so that you guys can actually see. So I'm going to have to completely change this guy, go into Desmos, and pull up my absolute value to get started on this one. So there's the parent. He looks like a V. I can flip him upside down. So that's him upside down. I can make him really wide. So now if I close all this out, you can see that the parent is that red V, and one of like the kids is that blue V that's flipped it now really wide. I can move it left and right, just like the last ones, up or down. I'll spare you me doing that so that you're not trapped on this part of the notes forever. But it's very important that you're understanding that the parent function starts out as this basic shape. So here it's this basic V, and then you can make a million other graphs that look like that by adding, subtracting, multiplying, dividing, and doing all and reflecting. So next one, he's new. This guy should be new to most of you. He's the square root function. And he is y equals root x. He is y equals root x. So all of our other ones had arrows on both sides, and this is the first one where it doesn't. So this has a domain of all reals. This has a domain of all reals, all reals, all reals. And now this one's the first one that doesn't because it has a closed dot there. The defining characteristic is that he's like a firework or a rocket. One side is a closed dot, and then the other side is an arrow. If I went through and changed all of these things again, I can change what that parent function looks like. So the red one is the parent, and then the blue one has been reflected and then like smushed down. It doesn't shoot as high. It's a lot lower than the red one. And then our last one is another one that you saw in 9th grade, and he's the final one. He's the exponential function. This guy is the exponential function. And this is the one that I'm seeing people miss the most on the quiz. His parent function is y equals 2 to the x, and this x is in the exponent position. That's why this is called the exponential function. So his defining characteristic is that he has one part of his graph that's flat, and then one part of his graph that's like really, really steep. So they describe this as like this, it's growing slowly right here, and then all of a sudden it explodes and gets very, very big. Does this one look familiar at all to anyone? A little bit? So just like on all the other ones, you can move them around, flip them upside down, stretch them out, shrink them, do all the things. Now, the last thing that I want to highlight before we start doing some whiteboard questions is sometimes they're going to give you the graph. Sometimes they're going to show you a graph and say, what is the parent function? And you're going to look at the shape of the graph. And if it looks like a roller coaster, you're going to say cubic. And if it looks like a weird fire looking guy, it's going to be a square root. But then sometimes they're going to give you an equation and you have to know what you're looking for in the equation. So if the equation only has an x, so we can have an x plus 5, we can have an x divided by 8, we can have a negative x, but if it's just x, it's linear. If you put a squared on it anywhere in the problem, it is a quadratic. If you have the power of 3 in it, it's cubic. These are the symbols that you would look for. The bottom 3 are a little bit easier. If there are straight lines in the problem, that means that it's absolute value. If you see the radical, that means that it's the root. And if the x is in the exponent position, that means that you are dealing with the exponential family. So before we go to our whiteboards, you have 6 problems down here. 3 of them are graphs, 3 of them are equations. You write the name for these families. So you actually write out linear. You write out quadratic. You have roughly a minute, or about as long as it takes me to walk through and see that you're actually writing things down. Light. Wake up. Yes. You just take it and go. So roughly 30. $20. About 10. 3. 2. Okay, this top one is the square root. He's like a firework that's shooting backward. What's the middle one? Quadratic. Number 9, cubic. 10. Great. How do we know? Because the x is in the exponent position. 11 is linear because all it has is this x. I mean, I know it has a 2/5 and a +1, but in terms of the symbols that we're looking for, it's just x. It's not x squared or x cubed or x trapped in a root or in straight lines. The last one is absolute value. How do I know? Because of these 2 straight lines right here. Those are the symbols that tell me that this is the absolute value family. So before we move on to the next part of this lesson, it is extremely important that you understand how to recognize what family you are working with. So I'm going to show you a bunch on my screen, and you're going to answer what they are on your little green whiteboard. I really think I need a new document. You are looking at the symbols. On these, I want you to write the equation. So I want you to write y equals x, or y equals absolute value x. If you're getting these wrong because you write the word, I'm moving your damn seat. Because you're not listening, you're too busy talking to your table mates. So make sure that you understand what I'm asking you to do. I don't want the name I want the equation, so I want this thing. Is it a y equals x family? Is it a y equals x squared family? Okay, here's your first one. You're giving me the symbols. Gabe, the pass is back. You can go now. You got about 10. These are not optional. Everybody has to hold up a whiteboard. If you don't know, leave it blank. 5, 3, 2. Okay, show me. Everybody has a little green whiteboard. You just gotta reach in there for it. Arla, are you holding one up there? Thank you. Y equals x cubed. This is your next guy. 10. 5. 3, 2. Okay, show me what you're thinking. Absolute value x. This time it's a graph. 10. 5, 3, 2. Okay, show me. Okay, this guy. 10. 5, 3, 2. Okay, show me. This is the cubic family. Very good. What is this guy's domain? Write that on your whiteboard. What's its domain? You can use any notation you want. What is this guy's domain? So what can x be? 10. 5, 3, 2. Okay, show me. If you don't know, just hold up a blank one. I think you'll be reminded once I tell you. All reals. This can be all reals because of these 2 arrows on the ends. This is not one of our function families. He does not look like any that we have. I mean, he's kind of like a weird parabola with an absolute value, but what is this domain? Try this domain. Ten. 5, 3, 2. Okay, show me. There you go. That last one seemed to jog your memory. -6 to 5, round parenthesis, square bracket. Okay, back to function families. What is this parent? Got about 10. 5, 3, 2. Okay, show me. Keep it up for a minute so that I can verify. Y equals root x. What are these? What is the parent for these? They both have the same parent. What is the parent? Ten. 5, 3, 2. Okay, show me. Y equals X. Okay, let's make them slightly more complicated. What is this parent? You have 10. What is the parent of that guy? About 5, 3, 2. Okay, show me. Aiden, hold up a blank whiteboard if you don't know. Y equals 2 to the X. This parent, 10. We got a couple of more and then we're moving on. 10. Five. 3, 2. Okay, show me what you think. Y equals X squared. We got 2 more. What is this family?
There was no square on the X though. Oh.
10. 5. 3, 2. Okay, let's see. Y equals root X. This is our last one before we move on. 10. 5. 3, 2. Okay, let's see what you have. This is the cubic family. Okay, let's take this cubic really quick and see what it looks like. So this is going to move us into transformations. This is the last thing we're going to do before transformations. So if I plug this big old thing into my Desmos. Okay, so on Desmos, I just want you to see what it looks like really quick. So look at the window side. Stop talking. Notice that this is where the parent should be. And what that function did was move it all the way up here. And that's what we're going to end, well, in a minute, what we're going to end what we talk about today with is what do all these things do? So all these things, what do all these do to make it so that our parent function, instead of being at the origin, like in blue, all of a sudden it is at where it is in red. Thank you. Is this making sense what we're doing next? Was that a yes or a no? Yes, dear. Yes. So it's actually a few things. It's up, over, and flipped upside down. So we're going to talk about how that happened. And to do that, we're going to jump to 7. We're going to skip 6 for now and jump to page 7.